So the question was, what is complex voltage? So where is the new slide? Voltage, current, resistance, power, etc. Okay. So just give me a time to get into flow of typing, then I'll type faster. Good, more people are coming. So AC circuits, complex numbers. The same things again. Okay, so this is the answer. What is complex voltage? So in DC circuit, we use real numbers. Same Ohm's law, V equal to IR, whatever. In the AC circuit, we use complex numbers. So why? It is not imaginary. It is two-dimensional. That's it. See, it is AC is a sine wave, right? So alternating current is sine wave. How do you represent sine? So to represent sine, we use complex number because sine will have what? Okay, so I'll write. So AC quantities are alternating, right? Which means sine or cosine waves. Okay, so how do you represent a sine or cosine wave? Representation. So we require three things, right? One is amplitude, then frequency, then phase. So to uniquely represent any sine wave with respect to other sine waves, so how do you uniquely represent person? Okay, maybe you have his mobile number, the unique number, or you have his. I think I should sit here. So to represent an AC quantity, we need these three things. Okay? Now, if I say that okay, frequency is fixed. Okay? So let's say we are talking about pure electrical engineering, not bothering with communications. Say communication technology. So what is your communication frequency? Okay, channel one is on 200 microhertz, channel two is on two. So they use multiple frequencies, frequency modulation, etc. So all that comes later in communication engineering. But in this simple electrical engineering, AC frequency is fixed. For example, our frequency is 50 hertz, and I think in Japan or somewhere they use 25 hertz. In US they use 60 hertz, something like that. As long as the frequency is fixed, you assume frequency is fixed. So now what is the representation then? If your frequency is fixed, then you don't have to specify. Okay. So now I can only represent using the amplitude and phase. So I just have to tell what is amplitude and what is the phase. That's it. Now what numbers are represented by these two quantities, amplitude and phase? Complex numbers. You call it imaginary. For all we know, I do a little bit philosophical now. For all we know, real may be imaginary and imaginary may be real. So it's just imaginary real are only variable or naming for the two dimensions. So now if there are no phases, then we just left out with amplitude. So then it becomes DC real number. Now another problem is there. See, every time we use amplitude, again, we to get the RMS value, we need to divide by root two. So you might be knowing. So simply, even they simply say that if we just say that AC quantity, it is actually the RMS and phase, not the actual amplitude. Just for that's again a convention. So now coming to your question, if somebody says V equal to 200 with an angle I don't have angle symbol, or maybe like this I will do. So if I say that voltage is 200 with an angle of 45 degrees, that means it is a phase. That's it. Nothing imaginary about it. You can always break it into imaginary and real, but just that is for only calculations. So only to apply calculations we use that. I hope that answers the question. See, very good. So one question one asked, everybody benefited. Okay, so like that. How much time? You see, I gave a exam, right? Exam two. So let's say if I take one set of questions, so how quickly can we solve them? Okay. So instead of again bothering you once again, ask question, I will assume that some student asking, sir, solve the exam for us. So that's what I will do. Yes. Since, but then if you have any questions, stop me in between. So all of you might have received this thing, right? So I will go with this one sample exam. Sorry. So first 10 questions, I think already one video is there, so I'll leave it. First 20 questions. So let's come to AC circuits. So those people who have AC circuit with these three parallel branches, this model, so they will get benefited now. So see the question, the second set of questions, either all three will be in parallel like this, or all three will be in series. The two models are there. Then if I go down, there is one more set of questions. So here, so Z1 is there and 2 and 3 are in parallel, which is in series with Z1. What is the other model? Some of you might have seen.
So, two are in, two parallel things in which in one of them there are two impedances.
So 1 and 2 are in series and
Both
overall
of
3
them
is
are
in
parallel
overall
with each other.
parallel with that. Okay, so that is another model. So what happens is the all series, all parallel, that will 50% will get all series, 50% will get all parallel. In the second one, 50% will get this one and 50% will get the other one. Where 1 and 2 are in series and 3 is in parallel. But anyway, so this happens to be one which I have selected. So let's work it out. Okay. So let's see. The time now is 11:18. So again, I will be going actually slowly, but it will feel like I'm going very fast. Okay. So you stop me if you didn't understand any step. Okay. So now the first job is calculating the impedances. Okay. You don't have to write notes because anyway I'm recording my screen. Let's check that. Yeah. So let's go back to. So how many of you use Ubuntu? Very few. A lot of people use. Okay. Anyway, so this thing work with your thing also. I'm right now. This is a Chromebook. So Chromebook normally doesn't have the Linux thing, but there's some ways I found out how to make it. So anyway, so just think that I'm working on the terminal. So there's an empty folder. So I create a file called some, what shall we call, a.py, just a simple name. And here uh, I'm writing a code in Python language. Okay? So first line is import CMath and math. So just these two are required to create. Now what I told for just here, I'll give comments for your benefit. So this is inputs. Then we have calculation. Then we have printing of the results. So these are anyway comments only, so nothing. This thing. So Z1 is a complex number. So there is a function called complex to define this thing. So now I'll copy this. Now what is a complex number Z1? So I go to the question paper. Read the first line. Impedance Z1 consists of resistance of 12 and inductance of 190. Okay. So what is the formula for converting, the individual components into impedance? So the real component will be 12. 12, sorry, comma, 2 into pi. Okay, so math.pi you have to use into frequency 50 into inductance. What is the inductance? 190 millihenries. Milli means e to the power of like 10 to the power of minus 3, but you can use scientific notation e power minus 3. Okay. Any doubts here? I am calculating the value of impedance Z1. It has two components, real and imaginary component. Real component 12 given the question. Imaginary is XL, reactive inductance is 2 pi f into L, 2 into pi into f into L. Okay. The impedance Z2 consists of 16 resistance and 60 microfarad capacitance. Okay. So how do we come? 16 is a resistance and 1 divided by 2 into pi into f into c. I keep forgetting 60 micro. So e to the power of minus 6, or it's not actually e to the power, it is exponent minus 6, and then one more closing bracket. Anybody have any doubt here? Again, we are converting the uh, given component values into impedance in ohms. Okay? The unit of all this will be in ohms. The question is it not minus 1 by? I think so, correct. Let's put minus. Okay. We'll see if the answer doesn't match, I will correct it later. So Z3 consists of 8 ohms and inductance of 65 millihenries. Okay. So 8 and 65. Okay. So 2 into pi into 50 into 65 millihenries. So now when if I
Sir, again, here as well you have to put it 1 upon, right, sir? In Z1 and Z3.
no
Z2 you
see
have to.
for inductance it is 2 pi FL. For capacitance, it is 1 by 2 pi FC. Okay, so that is the why all this. Again, we have a screen, right? So inductance, impedance, see like this. So these are the formulas. So XC is minus 1 by 2 pi FC, correct. He was telling minus, and XL is this one. Here, one thing you notice in this image, what is coming on the screen here, they did not give I. Okay? Actually, I will also be there. And Z is not R plus XC plus XL, it is R plus I into XC and I into XL. So, like that. So, yeah. So therefore, Z is a complex number. So let us check whether it works. So now I have given input here, and then I will do calculations here, and then I'll do printing here. So first, let us, without calculation itself, let us print whether the inputs are working or not. Okay, so how do I print? So print. So I use what is called as the F string. Okay, and then here I will say Z1 equal to Z1, Z2 equal to Z2, Z3 equal to. I hope this works. So I open one more tab to execute. So I'm getting the answers like this. So Z1 is 12 plus 59 I, Z2 is 16 minus. So minus coming means capacitor is there, and so on like that. So if I want to control the number of decimal places, I can do that by formatting this. So I go for 0.3f. Okay, so it 3 decimals it will print 0.3f, 0.3f. I think I have to remove the zero. Just a minute. So I'm getting the answers here. So I have three impedances. Okay. Now, how to find total impedance? So if I look at the circuit,
It's parallel to 1 upon.
now I have to find which tab it is. Huh. So look at the circuit on the screen. So three are in parallel. Okay, so what is the total impedance? So there's a formula exists or not? So ZT equal to 1 divided by 1 by Z1 plus 1 by Z2 plus 1 by Z3. So this is the impedance formula or same like resistance formula. In resistance we use real numbers, in impedance we use complex numbers. Yes. Ah, very good. Okay, so frequency is 40. So I did not even see, so I assumed it is. So let's change it frequency to 40. So for different students, it will be different. Okay. So now why it is important? Frequency is important because depending on the frequency, also the impedance values will change. So I think now we can compare also. By the way, I calculated ZT, right? So let's print that also. Let's make one more line. Print formatted string ZT equal to ZT, sorry, point. I'll use 4 decimals. Check the previous result and the present result. Okay. 59.69 was the previous reactance. Now the frequency reduced from 50 to 40. When you reduce the frequency, the inductance will reduce. So 59.6 became 47.7 ohms. Okay. So the inductance part reduced. Resistance part remains same. Okay. Again, please understand this concept here. Meanwhile, the capacitance part increased. So as you reduce the frequency, the inductive capacitance will increase. Okay. And the third one, the 20 became 16. Again, it reduced. Okay. By what factor it reduced? So it reduced by 4 by 5, 80% because 40, 50. Now, people will say inductor acts like a short circuit in DC. Okay. So now you understand that statement mathematically. In DC, the frequency is zero, so therefore the reactive inductance will be zero. And people also say in DC, the capacitor will be like open circuit. So capacitor blocks the DC. That is because 1 by 2 pi f comes in the denominator. So the reactance of the capacitor will become infinity and it becomes zero. Okay. That's another discussion. So anyway, total impedance I got 8.0097 plus 13.4831. The moment we have total impedance, what we can do? So I can find the I, right? So total current I can find because I know the total impedance. There are two different ways to find the total current in this example. Individually find I1, find I2, find I3, then add the currents. That is one method. Another method is find the total impedance and then find the total current by dividing with the voltage because the voltage is same for all. So let us define the voltage.
So,
So yes,
what was the first method, sir?
individually
Define.
I1, I2, I3.
How can we find that, sir? By dividing V by
I'll do
I1?
both methods. Yeah,
Okay.
just V by I1, V by I2, V by because V is common for all because it's a parallel circuit. So, but first we have to define the V. Okay. So, how do we define the V? See, oh, I'm forgetting. I think we have. Let's search. See, given the magnitude and phase, okay, so 220 is the voltage magnitude here on screen, and 30 is the phase angle of the voltage. Given the magnitude and phase, how to create a complex number from that? Okay, so Python uh, complex number from magnitude and phase. This is maybe to find the phase, I think. We need the reverse, right? Anybody knows how to do that? How to create a complex number given the, okay, it's real and imaginary conjugate. Anyway, we are getting some drawings also. So here you can see a plus b into I or b into j. So this is theta is the phase angle. Anyway, let's go back and let's try to search complex number magnitude. Let me just cheat a little bit. CMath.rect. Okay, that's what I have to use. See, V equal to. Okay. So inputs I am writing V equal to 220, right? Was it 220? 220 and 30 degrees. Okay. So given the phase and angle, it will convert into complex number. Now this 30 is in degrees. We need to convert into radians. So to convert these degrees into radians, we need to multiply like this. Okay. So again, I hope let's use capital V. Show the voltage. So any doubt here? So we are just defining. So I just did forgot the formula to do that. So given 220 as the magnitude and 30 as the angle, converted into radians. Okay, now calculations. I1 equal to I2 equal to I3 equal to. By the way, in Python there is a facility. It's called packing and unpacking. We can define like this. So V by Z1, comma V by Z2, comma V by Z3. So this is nothing different. Just individually it will calculate and individually it will assign to I1, I2, and I3. What is the total current? IT equal to I1 plus I2 plus I3. Now another way to calculate IT, let's say underscore A equal to V by ZT. Okay. So basically these two should be same. Two different ways of calculating. Let's print now. I come to the printing section. So print formatted strings. So let's print. I think I will copy this line. So here I1, I2, I3. Then I will say IT equal to, again 0 not required, and ITA. Okay, so two different methods we are calculating. Okay, any doubts after here? Shall I run this? Just printing the results. Yes, please. Huh? Multiply by 180 and divide by what? So same is the ordering, right? So it is same, right? ABC, ACB. But in phase sequence part, it is different. But anyway, so I'll save this. So let's run this. So I got the answers. Okay. So I1, I2, I3, three currents are there, and then I got the things like this. It is matching, right? So IT and IT both ways it is matching. So let's continue. Are we looking at the questions or are we looking at only diagram? So what shall we do? Shall we calculate the power in each? Okay. So let's calculate power in each. Okay. So what is the power? If I know I1 and Z1, how do I find the power? So I square into R, right? So you take the absolute value of I, that many amperes, and you take only the R and then multiply. So that will be I square into R. Yeah. So this 220 is already RMS. Okay. Now 220 already RMS, but here according to the function, the CMAT or Rex, right? This 220 is supposed to be the amplitude. That is how the Python developers have written the crect function. Okay? But you know and I know the secret that we are utilizing it, think that it is RMS. Okay? So these are just the what you call small things. So if I use V as RMS, then the I will be RMS. If I think that this 220 is amplitude, then whatever I calculated I, that is also amplitude. So that, yeah. Yeah.
Sir, so for Z3, so the I3 current, sir, it does not matter if like Z2 or Z1 are disconnected or connected, sir.
Okay, so there is a question on that, I think. So if I, so each one is independent, right? So because the same voltage is applied to all three, it is independent. So nothing will happen. Now, I mean, so if I change the value of Z2, I1 and I3 will not change. Again, you can, since you have the program, you can change the values and check. Meanwhile, here, what happens? Can you look at this circuit now? Uh, I don't know your name. The one you asked the question. Here, what happens? Another question. A part of the voltage is taken by Z1, and the remaining voltage is given to combination of Z2 and Z3. So whatever that voltage is there, let's call it V23 or something like that, or VB, VA and VB. Here the same logic applies, but then because the same voltage shared in series, then there will be a problem.
Sir, but if Z3 is connected, then Z2 would not affect. Z2 would not be affected.
Here, if I change Z3, what happens? I3 will change. Okay, but I1 is I2 plus I3. So the voltage of Z1 will change, which in turn changes the voltage of this part. Okay, so that is a connection. So that's why the two questions are like this. Yes, in this 40 voltage VAB, VAC denote the voltages across. Okay. So what is your question on this? How do you, see VAB and VAC are again complex numbers. Convert to polar. So then you will get two magnitudes and two angles. Okay. From that you can find. So for example, I'll give you. So let's say,
Sir, I think she meant the theory part, sir. Like, there was an option C, which
okay,
So second.
phase difference is not defined as components are overlapping. Uh, I don't even know the meaning of that, but anyway, it is a wrong option. Phase difference is defined. It can be zero or it can be non-zero. So phase difference anyway defined. So now the question is like this. So the choice is there to confuse people. So see, let's say I define some voltage or vectors. They are not even voltages. Two vectors are there like this. So here the magnitude is 45 and the angle is 125 degrees. Another vector, the magnitude is 60 and the angle is 150 degrees. Okay. So if these are the two given to you, so maybe currents, maybe voltages, maybe impedances, whatever. So here we can say which is leading, which is lagging. Okay, V2 is leading. Again, this is important. Everybody focus here. V2 is leading, V1 is lagging because V2 is 150 degrees. But how do you exactly tell that? Is imagine that there are vectors drawn for it. So V1 will be 125 degrees. So this is vertical 90 degrees, and then maybe this is 125 degrees, and one more vector will be like this. So this first one is V1, next one is V2. Okay. So if I were to stand at one location, let's say I stand, let's say this is my reference point. So the small, if I'm here, first this will come if they are all rotating in anti-clockwise direction. So we assume that they are all rotating in anti-clockwise direction. First this will come, then this will come. So V2 is leading, V1 is lagging because when the vectors are rotating anti-clockwise, which one will come first is leading. Anyway, let's go back. I think my time is running out. I should now start solving. Okay, so P1, P2, P3. P1, P2, P3. How do you get the powers? So here, absolute value of I1 square. So I think in Python, if you put two stars, it will square. Absolute value of current square into resistance. Okay, so what was the resistance? 12.
So that would be what, sir? Like actual power.
That will be in watts. So there is watts, wars, and volt amperes. So that will be in watts.
Like this
I1,
would be actual power dissipated.
yes, the actual power. That means the real power. It is called. Sorry, this is into. So I square into R. So 16. Absolute value of I3. I think here I have to make it I2. Square into 8. Okay. So these are the three powers I calculated. What else? Phases. Phase of I1 phase of I2, phase of I3. Okay. So I think because there are some questions, find out phase difference between 1 and 2, something like that. So how do you get the phase of an angle? So I think C math something is there. So this will be in. So I'm not sure. So let's check only with P1, PH1. Okay. So let us print the results. So again, I'll copy this, paste it here, and let me also print the phase of first. PH1. Okay, so let's run this. Okay. So I'm getting the power in P1, P2, and P3, and the phase of the first one is minus 45 degrees. See, already voltage is at 30 degrees, okay, and the current is minus 45. So total it is around 75 degrees phase difference between the voltage and I1. Anyway, so in the interest of time, let's come to the questions. Okay, so where are my questions? So question number 21, find I3. Okay, so I3 already solved. Okay, so 10.038 minus 6.747 I. Okay. So C is the answer for question 21. Question 22. Z2 is open circuited. Find the current I3. So the answer is same because it doesn't change. Okay. B is the answer here. Power factor of the circuit. So how do you find the power factor of the circuit? So because you have total impedance, from the total impedance you can find the power factor. Okay. So what is the total impedance? This one, 13.4, and this one, 8 plus J, 13.4. So here R by Z will be the total impedance, the real part divided by uh, the this one. That is the total impedance. Okay. So what is power factor? The definition of power factor is the angle between the voltage and the current. Okay. So okay, let's do that part that way, so that see what is the angle of the voltage. So here what I will do, I'll just copy this. Here PHT. Sorry. So I am using PHT, that means phase of the total current. So here I will use IT. Sorry. So now I have the phase of the voltage and phase of the total current. What is the phase difference and the cause of it? Okay, so power factor PF. Sorry. PF power factor is cos of. I don't know. Should I use math.cos? Cos of 30 minus. See, should you use voltage minus current or current minus voltage?
Voltage minus current, sir.
So in cos it doesn't matter because cos anyway both sides it is there, but typically we use voltage minus current. So 30 is the phase of the voltage given in the question. Now just now we calculated PHT, phase of the total current. Now but cos requires the value to be given in radians. So divide by 180 multiplied by mat.pi. So now I got the power factor.
Sir, sir, power factor is also a real part of power by absolute power.
Yes, so power factor is also real part of power by apparent power. So let's print first this one. So PF equal to PF. Sorry. Anyway, so I'll just run this. So I'm getting the answer 0.51. So already the angle of the total current is minus 29 degrees. Yes, voltage is at plus 30 degrees and the current is at minus 29 degrees. So minus 59 degrees is the total angle. And the power factor is 0.5107. Okay. There are many ways to calculate power factor. Let's do that. By the way, answer will be, oh, we need to be careful here because two answers seems to be close. 5107. So maybe I'll go with 511 instead of 510. Okay. Actually, I should try to keep it more far away, but anyway, in this case, it has come that way. So answer is B here by rounding off thing. Let's go back. Another way to calculate the power factor is PF2. Another way to calculate power factor is the real part of impedance. Okay. ZT dot real. Okay. So this ZT dot real will take the real component of the impedance divided by ZT dot, sorry, ABS of ZT. So this will also give that one. So I will print that also. PF2 equal to PF2 so I'm getting the same value. I can also use the impedance to find. So individually Z1 has its own power factor, Z2 has its own power factor, and so on like that also. So 24, 23 is solved. What is the active power supplied by the voltage source in the circuit? Okay, so if I want to know what is the active power, what I can do, I have P1, P2, P3, right? So I can print that. See this line, I am printing P1, P2, P3 individually. So here I will say total equal to P1 plus P2 plus P3. Okay, so I think can also give maybe two decimals is enough for that. So since individually I have calculated power, so here I got 1576.22 as the answer. So let's see. So what? Okay. So D is the answer. 1576.22. So D is the answer here. Next one, phase difference between currents I1 and I3. Now, phase difference between I1 and I3 we are asking, but which is leading, which is lagging, not given. So you just have to find the difference. So I don't know, is there a class at 12 here?
Yes.
Okay. So I'll just stop with this question. Anyway, we got individual phases, right? So manually we'll do it. So let's do one thing. I'll just pause it here. Okay, so in a different location, we are now continuing with the rest of the questions. So the question last we were discussing was number 25, phase difference between currents I1 and I3. Okay, so let's do that. So phi 1 was calculated here. So I'll just copy this line. Phi 2, phi 3. So these are basically the phases of three currents. Now I want the phase difference. Okay. So I'll say P diff equal to between 1 and 3, right? So I'll just simply take 1 minus 3 because the only difference is asked, so I don't mind the sign of this. So 1, 3. Okay. So here I will print that P underscore diff is the question. Okay. So here itself I'll insert it. pH3 equal to pH3. I'm just printing the 0.3 F. Then phase difference. P underscore diff 3 decimals. So here I'm getting minus 11.985. I can ignore the minus. So 11.985 is the answer. So here D is the answer for this question number 25. Let's go to question number 26. If the impedance Z2 is open circuited, phase difference between the current. So again the same, A will be the answer because the opening of impedance Z2 doesn't impact the I1 and I3 currents. They will remain same. If by replacing inductor or capacitor across the voltage supply, okay, by placing inductor or capacitor across the voltage supply, the power factor of the circuit becomes 1. Determine the value of the inductor or the capacitor. Okay, so what do we mean the power factor becomes 1? Power factor becomes 1 means the impedance will have only the real component. The imaginary component of the total impedance will become 0. So I'll go here. See, the question is how to make the power factor 1. See, now I will say, see what is the total impedance? Already we printed it here. The total impedance is 8.0097 plus 13.4831. So this is positive 13. That means the existing circuit has a reactance impedance. So to cancel that plus 13 reactance, I need to introduce a capacitance in parallel with the circuit. So what capacitance value will cancel that? So that is what we need to calculate. Anyway, I think I'll come back to that. Let's go to the other question because this requires little bit more coding. So I will come back to this question later. I'll go down. What is the active power loss in Z3 in the circuit? Okay, active power in Z3. I think already we calculated that. So 110, that is P3, right? 1170234. So I think D is the answer for this. Question number 29. What is the energy consumed in kilowatt hour by the impedance Z2 if the entire circuit was operated for 700 minutes? Okay. So energy is kilowatt hours. Okay. So it is power into time. Okay. So P2 we already have. I'll go to the code. See, I already have P2 value here. So from P2 value, I can calculate the E2. Energy in the second impedance is nothing but power in the second impedance multiplied by the time. Time 700 minutes. So 700 divided by 60, it will be hours. But the unit here is watt hours. So I will again divide by 1000 to convert to kilowatt hours. Okay, so now I got E2 in kilowatt hours. So here I will print the answer. Energy in Z2. kWh. So 1.94 is the answer. I think let me go for more decimals. Okay, I already have it here, 29. I think this is the answer. So let's continue. Finally, 30th question. So here there is a small mistake in the choices. This is supposed to be I2. So not I3, this is supposed to be I2. So Z1 and I2 are the current. So in the choices there is a mistake. So it's supposed to be I2. So let's find the phase difference between I1 and I2. So I go back to my code and then go to the calculation part. So here phase difference 1 2, PD12 I'll call it. So 1 minus 2. Now if it is positive, that means 1 is leading. If it is negative, that means 2 is leading. So let us see PD2. So the old result 1 I'll keep it same. This one will be 2, and here PD12. So let's look at this line. So phase of 1 is minus 45 degrees. Phase of 2 is plus 106 degrees. That means clearly uh, 2 is, I2 is leading I1 and the difference is minus 152. I can simply say I2 is leading by 152 or I1 is lagging by 152.3 degrees. So I1 lags, this one is I2. So the answer is B actually. So B is the answer. So this one instead of 3 you consider it as 2. So B is the answer for 30. So now only one question is left out, that is what needs to be inductor or capacitor to be added in parallel.